Human race has come a long way, evolving, inventing, shaping, and refining into today's lifestyle. Electricity serves as the major fuel in revolutionizing needs of this modern world, fulfilling basic necessity, running our homes, offices, industries, and even mode of transports. Electrical power has demonstrated pivotal role in origination of entertainment, medical surgeries, information technologies, robotics, and many other fields without which a mere imagination of long, happy, and healthy life is far-fetched. The need for electricity is endless, and its humongous production is done either conventionally through thermal, hydel, nuclear power, or with wind, solar, and other renewable sources. In India, more than 50% of the total power generation is achieved through coal based thermal power plants, currently having installed capacity of over 2 lakhs megawatt. Due to increasing concerns, utilization and management of this enormous quantity of fly ash produced during electricity generation has become urgent and challenging task. Following mandatory ash utilization guidelines opened window of opportunity for its utilization in various infrastructural development activities of the country. Occurring as fine amorphous particles of few 200 microns, fly ash is a ferroalumina silicate mineral constituting significant amounts of potassium, phosphorus, calcium, magnesium, and micronutrients like copper, zinc, manganese, molybdenum, and boron. Off-handedly disposed fly ash travel long distances, sometimes up to few kilometers, as fugitive dust emissions from fly ash lagoons, causing serious environmental and health issues. Hence, management of fly ash is major concern of coal-based electricity production in the country. ICFRE-TROPICAL Forest Research Institute Jabalpur has been working dedicatedly for over a decade with various thermal power plants of the country to provide solutions for different problems associated with management of fly ash. Severe problem of fugitive dust emissions from fly ash lagoons was reported at Sri Singaji Thermal Power Plant, Khandwa in Madhya Pradesh, causing turmoil in the lives of local people and farmers. Team of scientists and researchers from TFRI Jabalpur conducted detailed vegetation survey in the surrounding forest and non-forest areas to screen native dominant species suitable for plantation. Thereafter, plantation of the identified species of grasses, herbs, and shrubs was conducted by adopting proper cultivation and plantation techniques. This resulted in biological reclamation of fly ash lagoons within a short span of a year while controlling fugitive dust emissions from the lagoons. Construction of fly ash dike model was also proposed as long-term solution in the study. The proposed model will act as a physical barrier for mitigating impact of high wind velocity, which will restrict emission of fly ash particles to long distances. Another ash management undertaken by the institute was at Uttar Pradesh NTPC Dadri. The power plant has the country's first of its kind dry ash disposal system. Dadri Ash Mound is spread over 375 acres and envisaged to dispose fly ash of thermal power plant for operational period of 40 years. TFRI Jabalpur played significant role in recommending plantation of about 1.25 lakh seedlings, including 40 forestry and horticultural species having higher growth and natural regeneration capacity for stabilization of this ash mound. Monitoring long-term ecological impacts as checking growth of species like subabul against converting as invasive weeds was also recommended for the area. Working with NTPC Korba in Chhattisgarh, Tropical Forest Research Institute Jabalpur assessed tree plantation of the power plant for carbon stock and annual sequestration rate. Species-wise assessments over there helped in identification of higher carbon sequestering tree species of the area, which was then proposed for raising further plantations on ash mounds and lagoons of NTPC Korba. Selection of right species for plantation resulted in maximum sequestration of carbon dioxide from the atmosphere for mitigating impacts of climate change and global warming caused by the emissions released during coal-based electricity generation by the power plant. The plantation model proposed and raised at NTPC Korba has become a success in the region. The selected species are now being replicated in restoration programs of other thermal power plants in Chhattisgarh. In Ramagundam, Telangana, decanted ash lagoon water from thermal power plant is flushed out in Godavari River, which is used by nearby farmers for irrigation purposes, especially during lean months of the year. Ramagundam Super Thermal Power Plant approached Tropical Forest Research Institute Jabalpur to study the impact of this decanted water from ash lagoons on agriculture crops and soil quality. Sampling of water, soil, crops and vegetation from 10 locations was conducted by the institute scientists and researchers. Thorough assessment of macro and micro elements including heavy metal and trace elements was conducted using inductively coupled plasma emission spectrophotometer at soil laboratories of TFRI Jabalpur. Future strategies for monitoring any ill effects of the decanted water on human and environmental health were suggested based on the reports of the analysis. Tropical Forest Research Institute Jabalpur is also consulting for Adani Power Limited, providing technical guidance in establishment of country's only fly ash utilization park using forestry interventions. Spread over 24.95 hectares at Gondia, Maharashtra, the park will be dedicated for providing implementable forestry research for fly ash utilization and promotion. Wholesome research experiments, including that on germination and plantation of forestry species using fly ash and its impact on plant growth, nutrient uptake and toxicity, will be part of the park, having its own fully fledged laboratories, nurseries, experimental and demonstration plots. Among others, ICFRE-TROPICAL Forest Research Institute Jabalpur has also been associated with resolving assigned NGT cases related to the management of fly ash. We ensure and pledge to provide clean forestry-based solutions to the coal-based thermal power plants for management of fly ash.